Okay, the next problem I'm going to solve is with this unknown compound here. So it says that we have an element X forms an iodide and a chloride. The iodide is quantitatively converted to the chloride when it is heated in a stream of chlorine. Okay, so we have this metal iodide with chlorine making this metal chloride with leftover iodide gas. If 0.5 grams of this metal iodide is treated with excess chlorine, so we have enough, it's not a limiting reactant question, and 2.36 grams of this potassium chloride is obtained, calculate the atomic weight of element X and then identify element X. Oh goodness, so what are we going to do here if we don't even know the molar mass? What we can do is we can say, if I know the mass of this compound, and I know the mass of the other compound, according to law of conservation of mass, my moles of iodine must be, my moles of this metal must be conserved. So I could figure out how many moles these guys have by their relative molar masses. So I know the molar mass of 3 iodines, and I know the molar mass of 3 chlorines. And I know when I take the moles of these, this compound, this one metal and 3 iodines, and multiply it by the molar mass, I will get 0.5 grams. So now I have to work backwards. How many moles of this do I have? What is the molar mass? We can solve by putting in a variable. If I know the moles of potassium chloride, I can say moles times the molar mass of this metal chloride will give me this mass. But again, I don't know the moles. What I do know is that the moles of X here and the moles of X here have to be the same, according to my balanced chemical equation. So these moles of X and these moles of X need to be the same. So I'm going to set them equal to each other. And what I'm going to put in the denominator is my molar mass. But I don't know my molar mass. I know how much 3 iodines weigh, but I don't know the identity of this compound. So what I'm going to do is I'm going to say the identity of this compound, so the molar mass of X plus 3 iodines. Iodine on the periodic table times 3 is 380.7 grams per mole. And the molar mass of this X, which we don't know, plus 3 chlorines, which are each 35.45, gives me 106.35. If I take my mass and divide it by my molar mass, I will get moles. These moles should be equal to these moles, according to my balanced chemical equation. If I take my mass and divide it by my molar mass, it'll equal moles. And these two need to be equivalent because they're both a 2 to 2, a 1 to 1 molar ratio. So this is basically an algebra problem. You're going to cross multiply and divide. So I'm going to leave out the units for simplicity. So I have 0.5x plus 53.175, this is me cross multiplying, equals 0.236x plus 89.8452. Please don't take my word for it. Please go back through and make sure that my distribution was correct when I set this up. So now I'm going to combine like terms and then solve for x. Okay, so 0.5x minus 0.236x gives me 0.264x equals 89.845 minus 53.175 gives me 36.67. Now, when I get x by itself, it'll be the molar mass of my unknown element. So So that means X equals 138.9 grams per mole. And that's lanthanide, or lanthium. It's part of the lanthanide family group, but it's La. All right. That one's not a very hugely applicable problem in AP chemistry, but you might see it every once in a while. Definitely identifying unknown compounds is a very common thing, but something like this, I'm not so sure you'll see it, but you never know.